Listen closely. The reality you experience every single day is hiding a terrifying and fascinating secret. Deep beneath the border of France and Switzerland, physicists at Cern are designing something so colossal, so unfathomably powerful, that it almost defies human comprehension. We are talking about the Future Circular Collider, an underground ring spanning 100 kilometers built to smash particles together at energies radically greater than anything we have ever achieved. Why do we need such a beast? Because I have spent my entire life trying to unravel the fabric of reality. And let me tell you, our current understanding is broken. The universe is filled with dark matter we cannot see and dark energy we cannot explain. We are staring into a vast cosmic void, and this new machine is our ultimate flashlight. It promises to answer everything. It could finally reveal the true nature of space, time, and the very origin of our existence. But there is a catch, a paradox that keeps some of the greatest minds awake at night. When you push the universe to its absolute limits, when you attempt to recreate the catastrophic conditions that existed mere fractions of a second after the Big Bang, you are playing with the foundational code of reality. Some ask if opening this door might unleash something we cannot control, an event that could tear the very fabric we are trying to comprehend. Could a machine designed to answer our deepest questions literally destroy reality itself? I am Brian Greene, and if you want to understand the profound mysteries of the cosmos without the academic jargon, I invite you to subscribe to Brian Greene Theory. We are going on a journey into the unknown together. Imagine you are holding an antique, meticulously crafted mechanical pocket watch. You can hear it ticking. You can see the hands sweeping across the dial, keeping perfect time. But the casing is completely sealed shut, forged from a metal you cannot break or melt. You desperately want to know how it works. You want to understand the gears, the springs, the very mechanism of time itself, but you cannot open it. If you are a physicist, your solution to this problem is somewhat brutal. You take two of these pristine pocket watches, you put them on a circular track, you accelerate them to unimaginable speeds, and you smash them directly into one another for a fraction of a billionth of a second. The casing shatters. The gears, the ruby bearings, the tiny coiled springs, they all fly out in a beautiful, chaotic explosion. By taking millions of high-speed photographs of that flying debris, you can mathematically piece together how the watch was built. This is exactly what we do at the European Organization for Nuclear Research, better known as Cern. Except instead of vintage watches, we are smashing together protons. And instead of a racetrack, we use the Large Hadron Collider, a massive ring of superconducting magnets, 27 kilometers in circumference, buried deep beneath the lush green landscape of the Swiss-French border. We accelerate these microscopic particles to 99 and 91% of the speed of light. For the last decade, this magnificent machine has been the undisputed heavyweight champion of science. In 2012, it gave us the Higgs boson, the elusive ghost particle that explains how the fundamental building blocks of the universe acquire mass. It was a triumph. The discovery completed our grand mathematical rule book, a framework we call the Standard Model of particle physics. The Standard Model is our greatest intellectual achievement as a species. It is a stunningly accurate blueprint that describes the fundamental ingredients of reality. We celebrated, we popped the champagne. But then, as the years went by, an uncomfortable, very suffocating silence fell over the world of theoretical physics. We expected the Large Hadron Collider to show us more. We expected it to crack reality wide open and reveal a whole new hidden continent of physics. We desperately needed it to explain dark matter, the invisible cosmic glue that holds our galaxies together. We needed it to explain why there is an overwhelming abundance of matter and almost no antimatter allowing you and me to exist at all. 3. We hoped it would point the way toward a grand theory of quantum gravity, but it found nothing else. The Large Hadron Collider did exactly what it was designed to do. But in doing so, it revealed the terrifying limits of our own understanding. We hit a brick wall. We realized that our beautiful, elegant rulebook, the Standard Model, is woefully inadequate. It only describes about 5% of the entire universe. 5%. The other 95% is a pitch-black mystery completely missing from our equations. To see further into the dark, you need a much brighter flashlight. Enter the Future Circular Collider. Imagine taking our current awe-inspiring machine and making it look like a child's toy. This new colossal ring will stretch for 100 kilometers. It will smash particles with energies of 100 tera-electron volts. To put that in perspective, that is roughly the kinetic energy of a speeding freight train concentrated into a space 1 trillion times smaller than a single grain of sand. We are not just looking for new particles anymore. We are attempting to recreate the exact blistering temperature and catastrophic conditions of the universe as it existed a microscopic fraction of a second after the Big Bang itself. We are building this Leviathan because we are desperate. We are trapped in a paradigm that we know is broken, and we need raw, unadulterated brute force to shatter the current laws of physics and force the universe to give up its secrets. But there is a profound risk when you wield this much power. When you start tearing at the deepest, most fundamental layers of spacetime with unprecedented energy, you are no longer just an observer of the cosmos. And that leads us to a very unsettling realization about what might wake up when we finally turn this massive machine on. Look around you at the room you are sitting in. The sky outside, the empty space between the stars. We have a deeply ingrained intuition that empty space is just that empty. We assume it is the stable, permanent, unchanging background stage upon which the drama of the cosmos plays out. You intuitively believe that the universe is in its lowest, most relaxed state of energy. Why wouldn't you worry? It has been sitting here seemingly stable for almost 14 billion years. But what if that intuition is entirely wrong? What if the very fabric of our reality is resting on a knife's edge? To understand this, we need to talk about what empty space actually is. Because in modern physics, empty space is never truly empty. It is boiling with invisible activity. Imagine the entire universe is submerged in a vast invisible ocean. We call this ocean the Higgs field. You cannot see it. You cannot feel it. But you are swimming through it right now. As fundamental particles move through this ocean, they experience resistance. And that resistance is what gives them mass. Without the Higgs field, you would not exist. Atoms could not form. The universe would just be a chaotic storm of massless particles zipping around at the speed of light. Now, here is where the physics gets incredibly strange. Every field in physics naturally wants to seek its lowest possible energy state. Think of a heavy boulder resting on a mountainside. If you let it go, it will roll all the way down to the bottom of the deep valley below. Once it reaches the very bottom, it stops. It has zero potential energy to fall any further. It is completely stable. We call this a true vacuum. For decades, we assumed the Higgs field, the invisible ocean we all live in, was like that boulder at the bottom of the valley. We thought the universe had settled into its lowest possible energy state. But then in 2012, we finally found the Higgs boson particle. And when we finally measured its exact mass, a collective shiver went down the spine of the theoretical physics community. The mathematics revealed something deeply unsettling. The mass of the Higgs boson suggests that our universe might not be at the bottom of the valley after all. Instead, that boulder is resting in a shallow crater halfway up the side of the mountain. It looks stable. It feels stable. It has been sitting in that little divot for billions of years. But it is not at the true bottom. We call this precarious situation a false vacuum. And this changes absolutely everything. Because in the quantum world, things do not stay put forever. All it would take is an event energetic enough or a random quantum fluctuation large enough to kick that boulder out of its shallow crater. If that happens, the boulder falls. The Higgs field plummets into its true minimum energy state. If the Higgs field drops to a new energy level, the rules of physics change instantly. The mass of electrons would change. The forces holding atomic nuclei together would fail. The chemistry that makes biology possible would be wiped out. This catastrophic event would start at a microscopic point, creating a tiny bubble of true vacuum. But this bubble would expand outward in all directions at the exact speed of light. You would never see it coming. It would just wash over the Earth, completely rewriting the laws of physics, and erasing our entire existence in an instant. So, here is the mystery that keeps us up at night. We are about to build the future circular collider. We are preparing to smash particles together with 100 tera electron volts of energy. We are intentionally concentrating more raw, blistering energy into a single microscopic point than has occurred naturally in our cosmic neighborhood since the dawn of time. The machine is designed to force the universe to reveal its secrets, but we have to ask ourselves a very dark question. By pushing the boundaries of high-energy physics, by tearing at the fabric of a universe that might be resting on a false vacuum, could we accidentally provide the exact spark needed to kick the boulder off the ledge? Let us pause and confront a glaring paradox, a contradiction that sits at the very heart of this technological marvel we are trying to build. When you share these apocalyptic concerns, the idea that our machine might unravel the false vacuum or tear reality apart, many well-meaning physicists will immediately try to calm you down. They will point to the sky. They will tell you that nature has been running its own high-energy particle accelerator for billions of years. Every single second, the Earth is bombarded by cosmic rays. These are rogue protons and atomic nuclei blasted across the universe by exploding stars and supermassive black holes. When these cosmic rays slam into our upper atmosphere, they hit with energies millions of times greater than anything we could ever produce, even with the future circular collider. So the comforting logic goes, if nature has been smashing particles at these monstrous energies for 14 billion years, and the universe has not collapsed, why should we worry about a machine in Switzerland? It sounds reassuring, but I need you to look closer because that comforting logic hides a terrifying flaw. Think of two cars driving on a vast frozen lake. If a car loses control and hits a snowbank, energy is released. Ice flies everywhere, but the thick ice beneath them holds. That is a cosmic ray hitting the atmosphere. It is a one-sided collision against a massive yielding target. The energy scatters. But inside the future circular collider, we are not firing a particle into a snowbank. We are taking two microscopic bullets, accelerating them in opposite directions to a fraction of a percent below the speed of light and engineering, a perfectly symmetrical, completely head-on collision. All of that blistering energy is perfectly trapped and concentrated into a stationary microscopic point. Nature almost never does this. We are manufacturing an event so dense, so perfectly focused, that it forces the fabric of space and time to endure conditions it has not felt since the birth of creation. And according to the equations of general relativity equations, I have spent my entire life trying to reconcile with the quantum world. If you pack enough energy into a small enough volume of space, reality simply gives up. The fabric of space-time collapses inward. You create a black hole. As a string theorist, I have spent decades exploring the mathematics of extra dimensions. We believe that curled up within the microscopic architecture of the universe, there are hidden dimensions of space. If these dimensions exist, gravity might become incredibly strong at the quantum level. Strong enough that our new collider might just squeeze these protons tight enough to accidentally manufacture miniature black holes right here on Earth. This is the ultimate paradox. We are building an instrument of pure light, a machine designed to illuminate the deepest mysteries of the Big Bang. Yet, to force the universe to reveal those secrets, we might have to summon the absolute darkness of a black hole. Now, the standard defense against this nightmare scenario comes from my late brilliant colleague Stephen Hawking. Hawking proved mathematically that microscopic black holes should be harmless. They should not swallow the Earth. Instead, they should instantly evaporate in a microscopic flash of thermal energy, a phenomenon we call Hawking radiation. So we are safe, right? The math says the black holes will disappear before they can consume even a single atom. But here is the trap. Here is the paradox that breaks your brain. Hawking's calculations and the safety models that Cern relies on are built using the framework of the Standard Model and our current understanding of quantum mechanics. But remember what I told you, we are building the future circular collider specifically because we know the Standard Model is broken. We know it only describes 5% of reality. We are betting the survival of our planet on a mathematical rulebook that we already know is missing 95% of its pages. We are caught in a scientific catch-22. To prove our math is incomplete, we have to build the machine. But to turn the machine on safely, we have to place absolute blind faith in the very math we are trying to destroy. Now, let us push through the veil of everyday intuition and enter the realm that truly breaks your brain. Up until now, we have been talking about smashing particles as if they are tiny, microscopic billiard balls colliding inside a room called space and time. We picture space as an endless smooth container and time as an unyielding clock ticking in the background. But as a string theorist, I have spent decades staring into equations that tell us something utterly breathtaking and deeply unnerving. Space and time are not fundamental. They are not the stage bravery. They are an illusion. Think about a wave crashing on a beach. A wave is real. You can see it. You can feel its kinetic force. You can ride it. But if you zoom in with a powerful enough microscope where you realize there is no such fundamental entity as a wave, there are only trillions upon trillions of individual water molecules interacting with one another. The wave is an emergent property. It is a collective illusion created by deeper, simpler components. The most cutting-edge frontiers of theoretical physics suggest that space and time itself are exactly like that wave. They are not fundamental ingredients of reality. They emerge from something deeper, from the complex, intricate web of quantum information and quantum entanglement. Now ask yourself, what happens when you build a machine like the Future Circular Collider, capable of focusing 100 tera electron volts of energy into a region smaller than an individual fundamental particle? You are no longer just studying the water molecules. You are poking a hole in the very fabric of the wave. You are reaching beneath the smooth, seamless continuum of space and time and tearing at the underlying quantum pixels. If you smash particles hard enough, you reach a threshold where space itself ceases to have meaning. At those extreme energies, distance dissolves. The concept of here and there completely breaks down. In classical physics, if an event happens in Geneva, it cannot instantly affect an event on the other side of the planet without a signal traveling through space between them. But if space itself dissolves at the point of collision, a cause and effect lose their grip on reality. And it gets even wilder. In string theory, our math tells us that our universe does not consist of just the three familiar spatial dimensions of height, width, and depth, along with the dimension of time. To make quantum mechanics and gravity coexist without mathematical contradictions, the universe must possess additional dimensions. 9 dimensions of space, or 10, or even 11, all tightly curled up into complex microscopic geometric shapes, known as Calabi, Yau manifolds. They are so small that we walk right through them without ever noticing. When we turn on the Future Circular Collider, we will be firing protons into these hidden geometries. And here is the mind-bending reality: if those extra dimensions exist, when we smash particles together, some of the debris, some of the raw energy of the collision might actually leak out of our three-dimensional world and bleed into those higher dimensions. Imagine watching a high-speed collision in our detectors. You calculate the exact amount of mass and energy that went into the impact, but when you sum up the debris coming out, a huge chunk of energy is simply gone. It did not vanish into thin air, it vanished into thin space. It bled sideways into an extra spatial dimension that humans are physically incapable of perceiving. Think about what that actually implies. If energy can leak out of our universe into higher dimensions, it means those higher dimensions can interact back with us. It means our universe is not an isolated bubble. We are living on a thin three-dimensional membrane, floating in a vastly larger, higher dimensional hyperspace. Smashing particles at these extreme energies is not just about finding new microscopic ingredients. It is an attempt to punch through the walls of our three-dimensional reality and glimpse the higher dimensional multiverse beyond. We are threatening to shatter the foundational illusion that holds our perception of reality together. And when you begin to tear away the illusory framework of space and time, you are forced to ask if our everyday reality is just a delicate emergent projection. What happens to our world when that projection is disrupted? We have talked about the terrifying possibility of triggering a false vacuum collapse. We have explored the mind-bending reality of extra dimensions and the potential to tear the very fabric of space and time. But now we must face the hardest truth of all. As scientists, we are paid to be bold, to push into the unknown. But we must also be brutally honest with ourselves and with you. Look at this from a historical perspective. Every single time humanity has unlocked a radically new regime of energy, we have fundamentally altered our relationship with the universe. Think back to the summer of 1945 in the desert of New Mexico. When Robert Oppenheimer and his team of brilliant physicists were preparing for the Trinity test, the detonation of the first atomic bomb, there was a very real, mathematically grounded concern among some scientists that the sheer heat of the nuclear explosion might ignite the nitrogen in the Earth's atmosphere. They worried they might accidentally start a self-sustaining chain reaction that would set the entire sky on fire and end all life on our planet. They did the math. They reviewed their equations. They decided the risk was virtually zero, and they pushed the button. They were right. The atmosphere did not burn. Boop!